Have you ever wondered, what is nuclear energy? And why is it so important yet controversial? As we delve into this topic, we can't ignore the elephant in the room: nuclear accidents. These incidents, though few and far between, have left an indelible mark on our collective psyche, casting a long shadow over the promise of nuclear energy. Take, for instance, the Chernobyl disaster of the late 1980s. This catastrophic event in Ukraine saw a nuclear reactor explode, spewing deadly radioactive material into the atmosphere. The fallout was severe, leading to mass evacuations and transforming a bustling region into a toxic wasteland. The fear and dread associated with such a disaster are hard to shake off, and they have undoubtedly shaped our perception of nuclear energy. But Chernobyl is not the only incident that has stoked our fears. The 3 Mile Island accident in the United States and the Fukushima disaster in Japan have also contributed to the public's anxiety. The invisible threat of radiation, its harmful effects on the human body, and the lasting impact of these events have left a deep impression on our minds. Adding to these concerns are the security risks associated with nuclear materials. The potential for weaponization of radioactive substances is a genuine concern, and it's one of the reasons why public sentiment towards nuclear energy is divided. In fact, polls in the United States revealed that almost half the respondents would prefer to eliminate nuclear power entirely, a sentiment that has been influenced by the decline in public trust following incidents like Fukushima in 2011. But let's put these fears into perspective. When we look at a chart comparing deaths per unit of electricity production for various energy sources, we find something surprising. Wind and solar, often considered safe, have a higher death rate per unit than nuclear energy. Despite being quantifiably safer than fossil fuels, nuclear energy must grapple with a psychological hurdle that continues to shape public opinion. While nuclear energy can be safer than other sources, it battles a psychological hurdle that shapes public opinion. As we continue this discussion, we'll explore more about the challenges and potential of nuclear energy. The question of radioactive waste is another critical aspect of nuclear energy. Now, let's delve into the intricate issue of nuclear waste. There are various types of nuclear waste, but let's focus on high-level waste, the byproduct of spent nuclear fuel. This waste is incredibly radioactive, and its half-life, or the time it takes for half of the radioactive atoms to decay, spans thousands of years. That's a lot of time to manage something so dangerous. The challenge of nuclear waste lies not just in its radioactive nature, but also in its disposal and storage. Imagine having to store something safely for thousands of years. We're talking about a timescale that far exceeds human civilization as we know it. To give you a clearer picture, let's look at a pie chart illustrating the global distribution of nuclear waste. You might be surprised to learn that the majority of nuclear waste is actually low and intermediate level. However, it's the high-level waste that contributes most to radioactivity. Even though it represents a smaller fraction of the total, its radioactivity poses a significant challenge. So, how do we manage this waste? The methods are as diverse as they are intricate. In the United States, dry cask storage is a common method, where spent fuel that has already been cooled in the spent fuel pool is encased in a heavy, leak-tight container. There's also the proposed Yucca Mountain storage solution, which involves burying nuclear waste deep underground. Meanwhile, Finland is taking this a step further with the ambitious Onkalo project. This is an underground facility designed to bury nuclear waste in sealed tunnels. It's a massive engineering project, aiming to keep the waste isolated for at least 100,000 years. Then there's the concept of reprocessing, where spent nuclear fuel is treated to extract useful materials for reuse in reactors. This could potentially reduce the volume and radioactivity of the waste. However, it's a double-edged sword. While reprocessing could help tackle the waste issue, it also poses a risk of nuclear weapons proliferation, as the process can separate out weapons-grade materials. So, as you can see, nuclear waste management is a complex issue. It's a long-term commitment that requires robust and innovative solutions. But it also raises ethical questions. Are we comfortable leaving an enduring problem for future generations to deal with? It's a question worth pondering as we consider the role of nuclear energy in our future. The long-term nature of nuclear waste management is a concern, leaving an enduring problem for future generations. The economic aspect of nuclear energy is another crucial consideration. In the world of energy production, nuclear power stations are akin to the proverbial elephants in the room. They're enormous, not just in physical size, but also in the sheer scale of financial investment required to construct them. The high initial capital investment is often a significant hurdle for many countries considering nuclear energy. Imagine the costs associated with developing a small city from scratch. Now, add to it the complexities of advanced technology, stringent safety measures, and regulatory compliance. That's the kind of financial commitment we're talking about when we refer to constructing a nuclear power plant. Delving deeper into these complexities, we find that nuclear power plants are not your run-of-the-mill constructions. They house intricate systems designed to harness the power of the atom, a feat that requires cutting-edge technology. This technology doesn't come cheap. It demands extensive research, development, and rigorous testing to ensure safety and efficiency. Speaking of safety, nuclear power plants must adhere to the strictest safety measures imaginable. This isn't merely about preventing accidents, it's also about mitigating the potential impact if such an unfortunate event were to occur. Safety measures include robust containment structures, emergency cooling systems, and rigorous staff training programs. Each of these aspects contributes to the overall cost. Then, there's the matter of regulatory compliance. Nuclear energy is, understandably, a heavily regulated field. Compliance with these regulations is paramount, but it also adds layers of cost. These regulations cover everything from site selection and construction to operation, waste management, and eventual decommissioning. Each stage is subject to rigorous scrutiny, which, while essential for safety and environmental protection, adds to the financial burden. In the end, the economic challenges of nuclear energy are substantial. The high initial capital investment, the complexities of advanced technology, stringent safety measures, and regulatory compliance all contribute to significant upfront costs. This makes nuclear energy a costly proposition compared to other energy sources, such as wind and solar power. The high cost of nuclear power plants is a formidable challenge in the adoption of nuclear energy. So, what does this all mean for the future of nuclear energy? The journey we've taken today has led us through the labyrinth of nuclear energy, unearthing its complexities and challenges. We've dissected the psychological fallout of accidents, the spectre of which continues to cast long shadows on public opinion. We've grappled with the enduring issue of nuclear waste, a radioactive legacy that demands responsible management and long-term solutions. And we've acknowledged the economic hurdles, the high initial capital, and the intricate technology that make nuclear energy a costly affair. These challenges, while daunting, are not insurmountable. They highlight areas where innovation and dedication can transform nuclear energy into a viable and sustainable power source. But it's a path that requires careful navigation, balancing the potential rewards against the inherent risks. While nuclear energy holds promise as a sustainable energy source, it comes with its unique set of challenges. It is up to us to weigh the risks and rewards and make informed decisions about our energy future.